The last technique we want to look at is the so-called contrapositive method. The idea of the contrapositive method is that we move from an implication A implies B to the inverted implication not B implies not A. We saw something similar earlier when we discussed the treatment of if and only if statements. Please note that if we do such a rewrite, like it's shown here, both statements, A implies B and not B implies not A, are logically equivalent. We are not introducing some sort of error or modify, logically speaking, the theorem. Let's look at an example. If x squared minus 9 equals 0, then x equals plus minus 3. The contrapositive for that would be if x equals plus minus 3, then x squared minus 9 equals 0. So it's just another way of formulating the same theorem. It is important to distinguish between contradiction and contrapositive. They are very different techniques. The contradiction would be, for this statement A implies B, we would say we accept A, but we also assume not B to be true in violation of the implication. So both of them would be true, and then we show that a contradiction results. And from that we conclude that this cannot be, so that if A is true, B needs also to be true. That's how contradiction works. The contrapositive method, on the other hand, it assumes not B, and then it uses a direct proof to show that not A is true, and from that we then conclude backwards that A implies B. Let me give another example. So we prove, or we want to prove, that x squared, if that is even, then x is even. And we want to do that by the contrapositive method. For using the contrapositive method, this is equivalent to proving if x is not even, then x squared is not even. So we just invert the two clauses and also negate both subclauses. So this in turn means if x is odd, then x squared is also odd. However, if x is odd, then we can rewrite it as x equals 2 times k plus 1 for some k out of the whole numbers. And we can further rewrite that in the following, or we can rewrite x squared for that in the following way, leading us to 2 times the value in the bracket, this is a whole number, plus 1, which means this number will be odd. As a result, we got exactly what we wanted to show, namely that x squared is then also not even, meaning it's odd. Hence, we can say the contrapositive statement helped us to demonstrate that if x is even, this implies that x is even as well. Sorry, if x squared is even, then it implies that x is even is true as well. So this was our roundup of different methods for logical reasoning, which is one way of dealing with theories in general. And the examples that we used here in these slides are, of course, often simple mathematical statements. However, all of these approaches that we showed were fundamental logical ways of dealing with theories and deriving further conclusions from within a theory. So in this chapter we discussed the basic role of logical reasoning, and then we discussed a number of different proof techniques like the direct method, the proof by cases, the contradiction proof, the induction proof, and finally the contrapositive method. With this, I would like to thank you for your attention, and let's see again in the next chapter.